Hi, I'm Chris with Brooks Brothers Trailers. I'm here today with Travis Cross. He's a design engineer here at Brooks Brothers. Travis, this thing doesn't look quite as big as a Starship launch pad, but this is pretty massive. What is this thing, and tell us a little bit about it.
So this is our newly installed puller tester station. So
Okay.
the idea behind this right now is it gives us the ability to test our underground and overhead pullers to be able to, one, test the pulling capacity and make sure that all of the trailers that we're putting out the door are able to meet the qualifications that they need to, and two, it gives us a chance to calibrate it doing both a static dead pull load and a running rolling load by lifting a concrete cylinder off of the pad it's sitting on.
Okay. When you guys in the design team are designing something, obviously you have the 3D and the different testing methods on the computer, but the computer only tells us so much. I mean, it's probably really good, but this brings it to reality, right?
Yeah.
That's what we're trying to accomplish with this?
Simulations are always going to be simulations. They're getting better and better every day, but nothing beats actually putting it to the field and getting a proper test in place. One, structure is one thing, but some of the things that's hard to simulate is engine capacities, hydraulics. A lot of that stuff you just can't really account for until you actually get it out there and test it.
That. Right. Well, that makes sense. You've designed here, Travis. I mean, this is quite a nice looking piece of equipment.
Yeah. So we've got 4 different concrete cylinders that we have. They're all weighted to a certain poundage. So we have a 25,000, a 3,000, a 4,000, and then a 5,600. So the idea is for our overhead pullers, the 2,500 we would be able to test against our 2,000 pound puller to make sure that we can not only hit the capacity that we're looking for, but also to be able to go just a little bit further to make sure that nothing happens in the field, right?
Yeah. Could you give us a little explanation on the mechanics?
Yeah.
How does this tester actually work?
So we've got the concrete cylinders, as we mentioned before. They've got hooks on the insides, on the tops, that allow us to latch onto them on 3 different positions to get an even lift as it's being raised. It comes up, straight up, over 2 pulleys, down, and then it runs underneath the pulley that is mounted directly to a concrete wall around this. Now, the way this is set up is for our overheads. The idea is we can take this tray, lift the latches that are holding it in place, and actually slide it out, and gives us not only 20 feet up, but also 10 more feet down, so we have a full 30 feet of a rolling load that we can test.
Obviously.
So the overhead pullers, we've got those ratings, and then I don't know if they can see it or not either, but we've got a snatch block hooked up to the station here that's connected in a way where we can put the 4,000 pound cylinder on there and be able to actually simulate an 8,000 pound pull. So that snatch block is doing mechanical advantage, but it's actually reverse, so it's a mechanical disadvantage. So it gives us the ability to test those higher loads without putting anybody in a real dangerous situation of having to worry about lifting 8,000 pounds in real life.
That's great. Now that's a little over my head, but I'm sure it's going to work. And it's just another level of assurance that we can have before we send this product out to the field, that we know when a customer buys a specific rated machine that it's going to do what we need it to do for them out in the field. So with this test, this will work for underground and our overhead?
That is correct.
Both.
So chain drive, planetaries, 4-drum pullers, all the overhead systems that we produce, this would be able to test that, as well as our 5K undergrounds, our 8K undergrounds, both tracked and non-tracked. All of those, the 10Ks, all of that is going to be able to be tested on this before it goes out the door.
Excellent.
Make sure the tensiometer and everything is calibrated the way we want it to. Make sure the engine and everything is running the way we want it to.
Okay, excellent, because we have a full line of overhead, full line of underground, and this will serve purposes for all those. That's great.
That is the goal. Get that even test going. We will then disconnect the cylinder out. We'll slide the tray out. We will take the cylinder off, put the 5,600 pound cylinder on, roll it into place, hook it back up onto the system, and then do a dead load test, which would simulate if you were stuck trying to pull against something in the pipe, if it was stuck, or the conduit underneath. And it also gives us the ability to sort of max out what the puller is capable of doing. So this gives us the chance to actually put it to that maximum load to make sure that it can withstand that type of stress being put into it.
Yeah, great job on this project, Travis.
Yeah.
This has really been amazing. It's going to
really,
work well for us.
Really excited to finally get this up and running and make sure that we can get our equipment out the door.